Hello everyone. Today we're going to be going over one of my favorite synthesis strategies. It involves a terminal alkyne, using a strong base to deprotonate it and then making it do some sort of nucleophilic attack on something. Again, this is one of the best reactions you can do in synthesis because it just unlocks so many reactions you can do downstream. So your resulting product here will look something like this. You're basically gonna take that, get rid of the iodide, and add it right on. Quite simple. And then from there, you can do any sort of alkyne reaction. Then that could lead you to alkene reactions, or really any reaction involving an alkene. So, and then you can go from that, make it into an alcohol or something. It's quite awesome what we can do. So let's look at the mechanism of how this occurs. I'll tell you, this mechanism is quite simple. So we know a terminal alkene has one hydrogen, and that's just going to be linearly positioned, sticking right out, ready for a base to take it. Sodium, and then the NH2, we know that this is an ionic compound. It might not be inherently obvious, but sodium doesn't really want to make covalent bonds, so it just looks something like this. Positive, negative charge, so we'll draw just this. We'll omit the sodium just to keep things simple. It will have this geometry here, bent geometry. And that nitrogen, who's negatively charged, is going to be like, I am such a strong base. You know that this is a strong base. I mean, even if this is your first day in organic chem, you should look at NH2 groups that have a negative charge and be like, that's a strong base. It's going to steal that proton and dump electrons right onto that carbon there. So we get this here. We get a negatively charged terminal alkyne. What's going to happen next is we know that carbon with a negative charge is not too favorable, right? It's pretty unstable, and it can act as a nucleophile. There is a lot of electron density right there in that molecule. So what's going to happen is we're going to get some backside attack. Remember in your alkane chapter, your basic reaction mechanisms, we saw SN2, SN1, E2, E1. This is going to do SN2 in this case because this is a primary alkyl halide. So we just attack, and then iodide's kicked out, and we get we're gonna get that bond, that bond, that bond, that bond. Did I forget one here? Am I going crazy? Wait. That bond, that one. Oh yeah, I did miss a bond up here. Sorry about that. I do that so much. I just miss bonds. But this is what happens. NaNH2, or you could even use any really strong. It has to be a really strong base because the pKa of this hydrogen is quite low. So you want to use NH2 or H-, like you could use sodium hydride, for example, is another good one. So basically, yeah, you react it with that strong base, gets the negative charge, and it becomes a nucleophile. It can do a backside attack on something. It's going to kick out a leaving group and leave you with that. And then from here, we can do all sorts of reactions, right? This is very important in the lab if you're trying to come up with a synthesis. Alkynes are a good place to start. So hopefully you guys learned something. I have a lot of fun teaching this one. It's nice and simple, real easy, nothing too complicated. It's a good part of the alkyne chapter. Have a wonderful day, everyone. Peace.